Assalamualaikum class. In today's lecture, we will move forward toward our next data structure named as queue. What is queue? A queue is a linear data structure for which item can only be inserted at one end and removed at another end. If we contrast queue with stack, a stack is LIFO, last in, first out, while a queue is a FIFO, first in, first out structure. So, the example of queue in our daily life is we queue up while depositing a bill or a fee. So, the objective of queue is to serve the person in their arrival order. It means the first coming person is served first. Another real world example of queue can be a single lane one way road where the vehicle enters first, exits first. A more real world example can be seen as queues at ticket window or bus stops. If you remember, in stack data structure, we have used some terminologies that are related to stack that were push, pop, top of the stack. Likewise, in queue data structure, we are going to use some terminologies that are associated to queue. Data front, front means first element, rear, rear will point toward last element. In queue means insertion, insertion at rear. DQ means deletion, deletion from front. So the basic operation of queue that we're going to cover are in queue. In queue means insertion, insert X at the rear of the queue. The next operation is DQ. DQ means remove or deletion. Delete the front element and return it. Front. Front is equal to top of the stack and get. It will only display the front element without removing it. Is empty will return true if your queue is empty and false if your queue is not empty. And in the case of array, we're going to have an other operation or function that will be is full. Is full means is full return true if your queue is full and false if your queue is uh, not full. Implementation of queue. We are going to implement queue by using arrays and linked list as well. First, we're going to start with linked list. Like any other data structure, we need to decide from where we're going to delete data and from where we're going to insert. So take 2 to 3 minutes and decide what is the best solution of implementing queue using linked list. On this slide, there's a visual representation of singly linked list, so you get the idea of what we need to do. We need to decide about two end, insertion and deletion, in queue and DQ. As we know that, unlike stack, in queue we need two end, one end for insertion of data or in queuing of data, and other end for the deletion or DQ. We will insert a new element at rear end and we will DQ an element from the front. While implementing stack, we have discussed this that insertion work in constant time for either end of the linked list. Whether you are inserting a new record at the end of the linked list or at the start of the linked list, it will take constant time. But the problem arises while deleting. If we remove an element from the end of the linked list, then we need to set the last current pointer. And if we delete a record from the head or start of the linked list, it will take constant time. So it seems best that head of the linked list be the front of the queue because we will be deleting record from the front and insertion will be done at the end of the linked list. Two pointer will be used to implement queue, front and rear. Front is the first element and rear is the last element. We know that DQ will be done from front and InQ will be done from rear. When DQ function is called once the front element 1 is removed, as you can see that in the figure, and note that front pointer has been moved to the next element 7 in the list after removing the front element 1. Now if user call enqueue function to insert an element 9 in it, as you can see in the figure that the new element is inserted at the rear end, and rear pointer start pointing this new node with element 9. For the implementation of queue, you need at least 4 files. Node.h, because we are implementing queue via linked list, so we need node.h file. Queue.h is a header file. Queue.cpp is the function file, and main.cpp. I'm not going to explain node.h file and main.cpp. I believe you know how to write the code of node.h and main.cpp file. In header file q.h, we're going to create class q, and for that we need two data member, front and rear. You can also take int size for the counting of nodes or element. It's up to you, but that is not necessary. Front will point the first node and rear will point the last node. And member function, we need constructor and destructor. I'm not going to define constructor. Void enqueue, in dequeue, int front, and int is empty. We don't need is full function because in the case of linked list, queue will never become full. Here is the definition of enqueue function. The enqueue function is used to add an element in the queue. It inserts the element in the rear of the queue. At line 1, a new node object is created using the new node statement, and a value is passed. If user want to insert 1, then 1 is passed using the set function or set object function. You are familiar with this function, and the next pointer of the node will be set to null ptr. Now we need to decide if that node is the first node of your queue, or you are adding a second, third, or fourth node. So for that we need to add a check. If front is equal to null ptr, it means that your queue is empty and you are inserting an element that is the front and rear of your queue. So for that there's a check. If front is equal to null ptr, so front is equal to rear is equal to new node. In the case of one node, that node will be the front of the queue and that node will be the rear of the queue. So we have created a node that become front and rear of our queue. And what if user want to enqueue 7? We know that a new element will always be inserted at the rear end. So uh, what we're going to do, the newly created node that is 7 is set as the next node of the node currently pointed by the rear. So rear set next new node. We will pass the address of new node, and rear is equal to new node. The rear pointer is set to point the newly created node that is 7. After enqueuing 7, 7 will become the rear of your queue and 1 is the front of your queue. You can add as many elements as you want in your queue at the rear end. Dequeue function is similar with the pop function. First, we're going to store the element of the front node, and in the x variable, then we will assign the front node with pointer p or temporary pointer. Then front is equal to front get next delete p and return the value that has been deleted. It is quite simple. We have discussed in the class. No need to explain further. Front function of queue will return the value of front node without deleting or removing it, while the isEmpty function will return true if your queue is empty and will return false if your queue is not empty. You can do that by using the front variable. If front is equal to null ptr, it means queue is empty, otherwise not empty.